Engineering drawing and bill of material. We earlier learned about assembly drawing, and many of us have had the opportunity to create or develop an assembly drawing and have knowingly or unknowingly used the term BOM, that is bill of material, while developing such an assembly drawing. In this topic, we shall briefly learn about BOM, its definitions, features, types, and importance, and appreciate how it is different from part list. Bill of material defines the structure of an assembly or a product with defined relationship as parent-child tree structure. Let us understand this with an example of a car. From above, we see that a hierarchical structure is established between the final product and associated children. Similarly, we also notice parts have their own relationships established at next levels with their constituting child parts, etc. Car is, in this case, is a finished product in the current configuration and hence the level 0 part of this structure. Similarly, there will be parts at level 1, level 2 and so on in the product structure. With this, we now learned briefly about levels of bill of material. Note, there is no specific rule of ideal number of levels in a bill of material. It depends on the complexity of the product and associated assemblies or subassemblies. However, higher number of levels in a bill of material leads to complexities in managing bill of material. In most of the cases, a part can be used at various levels in the bill of material considering reusability aspect. Above clearly explains the where used situation of parts etc. in a hierarchical structure. Also, you learned about the relationships as well as levels in the bill of material. With the above, we may see bill of material as product structure with a hierarchical structure of items which could be components or parts, subassemblies, sub-subassemblies, or assemblies which compose a product as well as their attributes can be represented. The product structure or bill of material can be defined for finished product or semi-finished stages of product assemblies or sub-assemblies. This thus not only specifies quantities used of a part in an assembly or a product, also importantly defines where used, meaning which part is used where and what level in an assembly or a product. Additionally, the bill of material also indicates the unit of measure of each part used in the assembly or a product. We shall try and know a bit more on this. Sometimes, bill of material is mistaken with part list. As you create assembly drawings, you also need to define the bill of material, which generally is a listing of parts used along with their usage quantities to define the assembly. There are different types of bill of material used in industries such as engineering bill of material, manufacturing bill of material, service bill of material, shipped bill of material, or packaging bill of material. For now, it is important to know that engineering bill of material as defined during developing drawings and design of product is the key trigger of developing different other types of bill of material. Hence, a brief introduction of bill of material will help you to provide the perspective. Note, you shall be learning more on this topic of bill of material in our advanced course of new product development. Engineering drawing and bill of material. After going through bill of material topic, you would appreciate BOM is most important asset which is created by engineering team which guides production team to plan procurement and production activities. Engineering drawing and manufacturing drawing. We have learned that engineering drawing typically provides relevant information such as geometry, dimensions, tolerances, material specification, etc. for a part which is referenced in the drawing. We also learned that such information is used by different people in the organization for performing their functions. In this topic, we shall learn more about how engineering drawing leads to develop a manufacturing drawing, what is a manufacturing drawing, and why manufacturing drawing is created. As we discussed earlier, engineering drawing defines the geometry of an object or part, keeping in view the three key elements, namely fit, form, and function of such an object or part. This thus means that an engineering drawing defines the dimensions along with permissible tolerances so as the fit aspect of part is taken care of. Similarly, the function which such an object or part need to perform leads to the selection of material type while designing the part or object. All such information is available on a released drawing. Such released drawing becomes the basis of further realization of physical part or object, be it supplier development or manufacturing. Released engineering drawing is the primary input to planning engineer, who develops manufacturing sequence dependent on available manufacturing infrastructure as well as supplier ecosystems, capabilities and capacity. Above leads to development of drawings for raw parts, stage drawings, part holding fixtures. Apart from these drawing, assembly fixtures, tool drawing, die design and drawings, etc. are also developed. These are called manufacturing drawing. Note, all these are in the purview of manufacturing drawing as engineering drawing do not consider such aspect. Similarly, released engineering drawings of assembly or a subassembly leads to develop manufacturing drawings of staged assemblies or subassemblies to improve the ease as well as productivity of assembly process. Engineering drawing and manufacturing drawing. After going through engineering and manufacturing drawing topic, you would appreciate where and how manufacturing drawing is created downstream by production team. Manufacturing drawing is also engineering information and follows the same standard and best practices.